we're going to be talking about alternatives, one of the most important aspects of thinking, but also one of the most difficult, because it's really quite unnatural for the mind to look for alternatives. Normally the mind wants to look for certainty, this is it, security, certainty, not go chasing after alternatives. But we're going to look for alternatives today. I'm going to make a drawing here, and it's not a drawing of anything particular, it's just a drawing of a something. There's no one right answer. Then what I'm going to do is I'm going to ask you to give me suggestions as to what you think that could represent. There's no one right answer. Let's have some suggestions what you think that might represent. Fellow over there?
2 donuts on sticks.
2 donuts on sticks. Anyone else around this area?
Someone frying 2 fried eggs.
Someone frying 2 fried eggs.
2 hats on a hat stand.
2 hats on a hat stand.
2 Mexicans fishing.
2 Mexicans fishing. There's another version, 2 Mexicans doing something against the wall.
Polo plantation.
A polo plantation. That's a very good one. A polo mint plantation. Very nice one. All right, little fellow in front.
2 rings being thrown out pegs at a hoopla stall.
2, that's a nice one. 2 rings being thrown at pegs at a hoopla stall. The girl right behind.
Eyes on stalks.
Eyes on stalks. Very nice. Yes?
2 targets.
2 archery targets. Yes, that's a nice one. Also sometimes said to be targets for cross-eyed gentlemen, because you look at this one and shoot this one. All right, any others? Go here.
Skateboard upside down.
Skateboard upside down. Again, that sometimes leads to an interesting one where people say it's a dead roller skate. On its back with its feet in the air. All right, well, looking for alternatives there is easy and it's fun. There's no one right answer. We can move off in many directions. And sometimes looking for alternatives is quite easy. And the next exercise is alternative ways of doing things, which is also quite easy. What we've got now, 2 boards over there. If you'd like to bring those forward, Dinah. 2 boards and 2 pieces of string. And the idea is to cross the floor of the room in front of me, using the boards and the string in such a way that your feet, hands, clothes, or anything else doesn't touch the floor. And I'm going to ask for a volunteer first. I'm going to ask the gentleman, the little lad, immediately in front of me. Now, I want you to try that out. How would you use those boards to cross the room in such a way that your feet, hands, clothes don't touch the floor? Okay. Let's see, you go ahead. Okay, keep going, you're doing all right. Keep going, keep going. Okay, that's an approach, it's a good approach. Okay, fine, just sit down again. Okay, Dinah, let's see your approach. That's one way of doing it, certainly a perfectly feasible way of doing it. Another way might have been to stand on one board, place the other board in front of you, pick that up, stand on that, pick that up, using them as stepping stones. That might have been another way. And now we're going to look at a further way, I hope. Okay, that's enough, Dinah. Let's get a volunteer to do that one too. Okay, why don't you try again? Stand on it, hold it up, and hop across. Just a few paces. One hold it up quite taut under your feet. Okay, jump. Good, okay, fine. Sit down. So there we see that there was a perfectly adequate way of doing it, as the young fellow did, a perfectly adequate way, and then we looked for a better way of doing it. So in the first exercise on alternative, we were just free-ranging, finding alternatives. Here it was a matter of saying, we have a good way of doing it, but let's look a little further and see if there's a better way, which is much, much more difficult, because we're very rarely forced to look for that alternative. Now, the exercise I've got here is a somewhat similar one. And I've got a heavy ball, a steel ball. It's pretty heavy. And I'm going to roll it across here. And I just want you to think to yourselves for a few moments what sort of barrier you might put up here which would stop it going forward. Just the characteristics of a barrier you might put up here which would stop it going forward. Just think to yourselves for a moment. I won't ask you, I'll just go through it. But just think what characteristics the barrier might have to stop the ball going forward. Well, what usually happens with this, I'll just go through some of them. What usually happens, people say, well, the barrier should perhaps be rather heavy, a book or something, so the weight will stop the ball. Or they say if it's not heavy, then perhaps it ought to be strong and stuck to the surface, so again it stops the ball. Or indeed, you might say, let's have a bit of double-sided sticky tape, so the ball will gradually slow down. All these are perfectly correct, useful ways of doing it. But if we got trapped by it and said the barrier must either be heavy or fixed to the surface, we would be leaving out a whole range of alternatives, including the one I have here, which I hope works, which is so light that you can blow it away, and yet which acts as a reasonable barrier, I hope. And what it is just a folded piece of card or postcard, and I'll draw how it's folded. It's folded like this. And as the ball rolls onto it, the ball rolling there pins it to the surface and forms a strong barrier at the end. Now, it's no better than any of the others, but it certainly is different from the others. And the point I want to get across here is that very often we have an adequate way of doing things, like these are adequate ways, but we need to make an effort to look for alternative ways which may be better. And in the next problem, that leads to a solution where the ordinary way may or may not. And this one, again, I want you to think about quite quickly. And I'm going to put these discs up here. And what the discs will form is a triangle. And that triangle is obviously pointing upwards. And the task is to get the triangle pointing downwards, moving the least number of discs. Just think of it for a moment or two. Moving the least number of discs, get it pointing downwards. Well, this is a case where it really depends on the way you look at it. And we find an alternative way of looking at it. And if instead of looking at it as a triangle, we look at it as a rosette with 3 points, then it's very easy. We just move the points round to the next position. And you get it pointing downwards. So that's a case of an alternative way of looking at something which allows us to move forward. So in all this, we're dealing with alternatives. Alternative ways of doing things, alternative ways of looking at things, and so on. Now, the next one I want to show you is a game which I invented some years ago, and it was invented after a conversation with a famous mathematician at Cambridge, Professor Littlewood, and we were discussing chess, and we agreed that chess was difficult because it was complex and had so many pieces. So as a challenge, I decided to invent a game that was as simple as possible, and this was the result. And in this game, each player has only one L piece, which you can move to any new position you like in your turn. That's the opening position. After you've moved, you may, if you wish, move one of the red pieces, which don't belong to anyone. Now, supposing you were blue, I want you to tell me how many different positions for your L piece can you think of in that opening move. Let's have some suggestions. Just think for a moment. How many different ways could you place the L piece? It's enough if only one of the little squares is different. Let's have some suggestions. The different ways, yes?
5.
5. Let's see. There's 1 there. There's 2. There's 3. There's 4. Which was the 5th one? Which one have I left out? That one.
Yeah.
That one. Any advance on 5? Anyone?
Well, have you used the one where it goes across the top, then down? Is the other side?
Come and do it. Just place it as you think I ought to have placed it. That one. Could be. I thought I did, but anyway. Okay, maybe. Okay, so in that case, there's a fixed number of alternatives. You can't go on imagining more and more. There's a certain number, and you find them or you don't find them. Now, what about the next situation, which is somewhat in between? And the next situation I want you to do on the acetate sheets you have. And what it's going to be is this. I want you to tell me how many different ways you can think of for dividing a square into 4 equal pieces. The pieces have to be the same in size, shape, and area. Many ways is possible for dividing a square into 4 pieces. 4 equal pieces, as many different ways as possible. Okay, let's go through those ways of dividing the square up. Some of the fairly obvious ones are where we just draw that, or we just draw that, or we just draw down the middle and draw that. You could also have one where you divide it into 2 halves, and then you divide the halves into 2 halves again, and you can do that in a number of ways. You might divide them into 2L pieces, many, many varieties of doing that. Then there's another one in which you would divide this into little squares. For example, here I'm dividing it into 16 little squares, and then I can take different arrangements of the little squares. I might take that arrangement, which is the sort of L-shape arrangement, and so on, and there are other arrangements. Those are some of the more obvious ones. Now let's see if there's any other ones which anyone has. Any volunteers? Anyone? Okay, let's collect some of those up. I'll put them up fairly quickly.
Just different.
All right, let's have those 3 for the moment. They've got to be equal pieces, remember, equal in size, shape, and area. Okay, that's a good one. We'll come to that in a moment. It's a pretty general principle in that one. This one, there are 4 pieces, but, oh yes, that's all right. Fair enough. That's interesting. Yes, they're equal. Okay. Some of these, they're not equal in area. Okay, there's some general principles there. And in fact, there's an infinite number of ways of doing it. One way of getting the infinite number, which was suggested in some of these, but there's a general principle, is we draw our square, and imagine we draw the diagonal on a little disk, like that, and then we can rotate that as slowly as we like, and each point we stop, obviously, is another position. And as we can rotate it infinitely slowly, there's an infinite number of ways. Another way of getting the infinite number, which again was suggested in one of the ones you gave me, is if you take the center point and you take a position, any position along the side, and the same position along any side, and you draw a line of any shape towards the center, and repeat that line all the way around, this can be any shape, then you get an infinite number of ways of dividing it like that. And then there's another one which is somewhat similar, really it's part of that, where imagine we draw the diagonals, and then you change the shape of one of these. Suppose we change that, and we change the shape of each one the same way, and you get an infinite number as well. Now, the point I want to make with that is that sometimes in a situation, we think there are these alternatives, and then there cannot be any more. We've exhausted all the alternatives. And that's the time we really need to put a little effort into going further, saying, what are the alternatives? And indeed, in business in general, what usually happens, which is a pity, is that people put a little effort into getting alternatives, and then they put all their effort into deciding between them. And business schools and others put all the emphasis on decision between alternatives. And yet, in practice, it's often just as useful, I won't say more useful, just as useful to put a lot more time turning up additional alternatives for decision and action there, rather than just feeling that business decisions are only in the decision area. Now let me move on to another very important point about alternatives, and there's a true story which happened to me about 6 months ago, and I was in Los Angeles, and I was catching a plane to Toronto, and I had to wake up at 4:30 in the morning, 4:30 in the morning. So I set my alarm clock, and there was one of these rather nice, elaborate bedside alarm clocks, which I set at the right time and so on, and 4:30 came, and this alarm clock gave off a very loud noise, racket, buzz. So I woke up, and in order not to wake up all the neighbors, I turned and pressed the button to switch it off. Nothing happened. I then pressed the button to change from noise to radio. Nothing happened. I then pressed the alarm set button. Nothing happened. I then pulled the plug out of the wall. Nothing happened. It still went on making a racket. That's not so surprising, because sometimes they have batteries in case there's a power cut. I then put a pillow over the whole thing, and nothing happened, still making a loud racket. I now had 2 choices. either to ring up reception and say very feebly, how do I turn my alarm clock off, which is very feeble, or to put the whole thing in a bucket of water and hope that stopped it. It was only then that I realized that the noise was not being made by this clock, it was being made by my other little alarm clock, which I'd set and totally forgotten about. Now, the point of the exercise was, the point of my saying it, is that at no point did I even stop to consider whether there was an alternative source of the noise. It never occurred to me that that was a situation for looking for alternatives. And this leads to a very important point about our search for alternatives, that where we're asked to, as I have been asking you, that's not too difficult. But where we're absolutely convinced that this is the only way, the only explanation, we don't really make an effort to look. And indeed, there's something which I call the Village Venus effect. And the Village Venus effect is that if you live in a small village, then the prettiest girl in the village, that's supposed to be a pretty girl, and even though it doesn't look very like it, the prettiest girl in the village is necessarily the prettiest girl in the world because you can't imagine anyone else. Similarly, in science and other areas, if we have a theory and we cannot imagine any other theory, we are convinced that it is right. And indeed, this is something which in one of my books I wrote up, what I call de Bono's second law, which is that proof is often no more than lack of imagination. Lack of imagination and think of an alternative, we are convinced that this is the explanation, this is the proof. And indeed, to some extent, Darwin's theory of evolution is still based on that. It is simply our lack of imagination of thinking of a better theory, which is really the only proof for it. There are now various other theories, even theories of non-genetic evolution, how the chemistry of the mother affects the chemistry of the child, affects the chemistry of the child, and so on. But that's a whole other area. Now let's move on from that, and let's move towards something practical. And the practical thing I want to talk about is what I call an APC. That sounds like jargon, but it's really just a set of initials which allows us to talk about something. APC stands for alternatives, possibilities, choices. All the things we've been looking at in this exercise. And there are two ways of doing it. We can either look for the alternative explanations of why something has happened, or we can look for alternative courses of action that we may have to choose in order to do something. And to save time, I'm going to give you both those at once. So one half of the room will look for alternative explanations of the situation I'm going to tell you, and the other half of the room is going to look for alternative courses of action. And the situation is this. I want you to listen very carefully because it would take too long to write. What it is this. You're in your car at a petrol station and someone drives up in a car belonging to a friend of yours. You recognize the car, and the person who gets out is not a friend of yours, it's someone else, and this person proceeds to do something very strange. He proceeds to pour what appear to be cans of beer into the petrol tank. So there's this strange person in your friend's car pouring what appear to be cans of beer into the petrol tank. Now, this half of the room, I want you to tell me alternative possible explanations. This half of the room, I want you to tell me alternative courses of action that you could do. All right, so work in your groups, the groups we formed beforehand, alternative explanations, alternative courses of action. All right, let's continue. Let's continue. Let's see what we've got and be fairly crisp and direct. Let's have some alternative explanations first. Let's have some from the front group first. Alternative explanations, okay?
We thought it could be a friend of the friend.
Yes.
Who was experimenting because he'd heard that cars could be run on alcohol.
Fair enough. Very good. He may have got it wrong, but a very good explanation. Little lady here in front row. Front row.
A garage mechanic, and the cans that they only look like beer cans.
Yes, good. It may actually have been petrol in the cans, and for some reason he's putting in beer. Some other in the back first. Let's have some in the back. Yes.
We think he was drunk and he's putting beer in his friend's car.
He was drunk and he's putting beer in his friend's car. Perfectly reasonable explanation. Not a reasonable thing to do, but a reasonable explanation. Yes.
It could be an advertisement for beer, reaches parts other beers cannot reach.
Yes, okay.
Candid camera stunt.
Yes, camera stunt. All right, let's have some alternative courses of action. In front.
Ring the friend.
Ring the friend and say, I've seen your car with a strange going on. Okay, perfectly reasonable.
Talk to the driver of the car.
Talk to the driver of the
There's
car.
obviously a lot of things, choices there. You can.
Yes, a lot of choice. What you talk to him about. Yes, okay. Do nothing's obviously another one. What?
Ask him whether his car drinks beer.
Ask him his car drinks beer. Yes, gentleman there.
I think I'd call either the police or the local mental hospital.
Okay, the lady in the middle.
Ask the garage man to keep an eye on him while you go and phone your friend.
Yes, that's a good one. Okay, last one.
Take the keys from him, make sure he doesn't start up the engine.
Yes, fair enough. All right, a number of different courses of action, a number of different explanations. Now let's look at a general point that finding alternatives is worth doing, but in the end one's still got to be practical. And I think it was Sir Robert Watson Watt, the inventor of radar, who said you get one idea today, you get a better idea tomorrow, you get the best idea never. And I fully agree with that. But what I do think is that when we get the first idea, the first explanation, the first solution, there is no reason whatever why that should be the best. And a little more thinking for that, but then have a practical cut-off. Fair enough, we've made a little effort to find an alternative, now let's proceed with it. The same thing happens with design. If the designer is always changing his design, then the production people say, for God's sake, freeze your design, because we've got to produce this thing. So on one hand, we should look for alternatives. On the other, we've got to be a little practical. Now I come to the end and really summarize what we've been talking about in this part in looking at alternatives. The first is that alternatives can be used in a whole number of areas. They can be alternative courses of action. They can be alternative explanations, hypotheses, theories. They can be alternative designs. There can be alternative ways of looking at something. Remember the triangle of coins and discs. The second point is that the first way we get, the first answer, the first explanation is not necessarily the best. A little effort beyond that to find others. Also, when we think we've exhausted all the alternative courses of action, instead of rushing into decision, a little more effort to see if there are other courses of action. I'm told there is an old Jewish saying which says if there are two courses of action, always choose the third, which is a good way of expressing the point. Then we come to the third point, what I call de Bono's second law, which is you have to figure out what the first one is, or read a book for that, which is that proof is often no more than lack of imagination in thinking of an alternative. And very often we get bogged down and say, this must be so, this is the only possible explanation, simply because at the moment we cannot imagine any other. The fourth point, the practical point, which we can say to ourselves or say to other people, let's do an APC at this point, let's see what other alternatives there are at this point, whatever it is, design, plan, explanation, or something else. And the final point is the practical point that though we look for lots of alternatives, in the end we may have to come down and choose one and proceed with it. Once or twice the business people have said to me, if you encourage us to look for more alternatives, you're making life difficult for us, because if we think of 4 instead of 2, you're doubling our work in deciding between them, which is quite true. But someone who says that shouldn't be in business, because you cannot improve your decision by impoverishing your alternatives, and the purpose of business is to be able to make decisions. So we've looked here in this part, we've looked at alternatives in thinking, that there are some things we do, and we look at any time for alternatives in all the various areas we've looked at. So alternatives and thinking. Thank you.